Hello, I'm Matt Cederberg, co-founder of T Splines Inc., and thanks for joining us for today's T Splines Tips and Tricks webinar. Kyle Houchens, T Splines trainer and experienced designer and also the owner of the Outside Digital Art and Design, will be sharing the tips and tricks today. Kyle, are you seeing my right screen?
I am. You're good to go, Matt.
Okay, great. So just as a little bit of introduction to this webinar, we do webinars about monthly, and generally the audience of these webinars is new users who have never used T Splines before, and we're starting to get enough comments and questions about going a little bit beyond that. So what we've done with this webinar is compiled some tips and tricks that Kyle and other designers and some of our internal T Splines staff have put together. And the hope is that coming out of this webinar, you who have used T Splines a little bit will be able to use it a little bit more smoothly, save some time, make some better models, and just use the program more effectively. So the way that these webinars work, if you haven't joined us before, is all of the attendees are muted, and we interact with you by you typing in questions in the box at the side of your screen. So then throughout the webinar, we'll be typing back answers, and then also we'll either interrupt Kyle if it makes sense, or Kyle will answer more questions audibly at the end of the webinar. So please keep the questions coming. That's what makes this the most valuable for everyone. Now, before I turn the time over to Kyle, I'm just going to we're going to start with a poll so we can get a better sense of really what everyone's experience is. So if you can just go ahead and answer this poll about how long you've been using T Splines, whether you've not used it at all yet, whether you've used it for under a month, 2 to 5 months, over 6 months, or over a year. This can help us kind of understand where everyone's at and hopefully tailor our instruction a little better. So let's leave this poll open up for another 5 seconds or so. Okay, closing in 3, 2, 1. And let's go ahead and share the results of this poll so everyone can see this. So as you can see, it's a pretty even split across all of that. It looks like the slight majority have actually never used the program, but 20% of you have been using it for over a year. So my concern is if you've never used T Splines before, this might not be the right way for you to start out. If you actually go to our website, let me see if I can pull this up. If you just go to our tsplines.com website and you go to, actually we have these 2 places, but if you just go to our webinars page here on the case study on the community tab, here you'll find a number of webinars, and some of these are especially good for beginners. I especially recommend this bike frame from a simple 2D sketch webinar, and the helicopter webinar is great, the iron webinar is great. Those would probably be the best way for you to really get a good introduction to the product. So feel free to keep on watching, but if you anyway, if you get lost, then maybe just go back to your day job, and we'll have a recording that's available later, and you might want to start off by watching one of these. So with that intro, let me turn the presentation over to Kyle. And actually, just one more thing, as you exit the webinar today, we've put up a little survey that will pop up when you leave, just with some questions about your experience, and if you could just answer that to help us make these webinars more helpful, we'd really appreciate that. So here you go, Kyle.
All right. Hello, everybody. Thank you for coming. I appreciate everybody taking the time to join us here. Basically, what I want to do here is I kind of polled everybody and some of the T Splines developers and Juan Santiago, who many of you have had the pleasure of dealing with on the forum, and Matt and some of the other people. I find that people who are really talented and who do this a lot of times for a living always have these cool little bag of tricks that they keep kind of stashed, and it's stuff that they found out over the years that they use, and I always try and every chance I get when I meet somebody who does the same kind of stuff that I do, to kind of, you know, show my bag of tricks and get a peek into theirs. And so the purpose for this webinar was to kind of share a little bit of that. We put together a few of our favorites, and this should be pretty short and sweet. Hopefully there'll be one or two little nuggets in here that you'll get that will help you along your way, and encourage you to kind of keep digging into T Splines here. So with that, let's go ahead and jump in. And the first thing I want to show you is a couple of things about the manipulator that may have not been readily apparent right on the surface. And to show this, basically what I'm going to do is start with just a simple sphere, and basically the manipulator can obviously be changed up here in the heads-up display by clicking the labels up here, or they can be accessed through hotkeys, which if you look at your keyboard, it would be the top row of keys starting from the Q, and it would be the Q hides it, the W brings up the translate, the E brings up rotate, R brings up scale, and T allows you to change the location of the manipulator. You notice if I hit the T key, the manipulator disappears, and up in the command line here it says pick a point. Well, I can snap that to anywhere in the model. If I do that again and snap it up here, or do that again and snap it down here, I can move the manipulator around in the scene, which is particularly useful for scaling or rotating. So that's one little trick, being able to access it through the hotkeys on the keyboard. The other thing that's kind of cool about the manipulator is if you double-click one of these icons, and in this case I'll be using the scale icon. If I double-click the scale 3D, you'll notice up in the top it says enter a scale factor. And what I can do in this case, if I want to double the size, I can just hit a scale factor of 2, and the object doubles in size. If I double-click it and I hit, say, 0.5, it'll jump down half scale. And that works on any of the handles. So I can scale in one dimension, or I can scale in 2 dimensions just by double-clicking and entering something in the command line. This is particularly useful when you're using the translate manipulator, because you can control, in this case, I'm going to move 5 units in the Z, 2 units in the Y, and 3 units in the X. And it allows you to precisely place your object in a situation where you would need that kind of numerical control. The other thing that's cool, and this was from Tom Finnegan, is kind of in the rotate manipulator. You notice if you grab each one of these rings, you can rotate it. But if you hold down the Shift key, you'll see that the rotate manipulator actually snaps in 15-degree increments. Actually, it looks like it's 5-degree increments. And unfortunately, there's no way to change that setting, but it's something that's kind of like a little Easter egg with this particular manipulator that allows you to go in and rotate it precisely by 5-degree increments. So if you want to just move it and count them out, you know that you can go in any direction in increments by holding down the Shift key. So the other thing that I want to look at is the different drag modes in relationship to the manipulators. And this was one of Matt's tricks, and I actually thought this one was really cool because I hadn't used it before. And I was playing with it a little bit this morning.
Kyle, just as you're getting into this, I just want to emphasize that I didn't want to scare anyone away by saying this wasn't necessarily a beginning webinar. If you have any questions at all about anything this Kyle is showing, we've got some people standing by and they'll answer any questions at all. So we hope that you get full value out of everything. So yeah, feel free to ask questions about any of this stuff.
And in the spirit of tips and tricks here, if you see something on the screen or you have a trick that you like that's relating to what we're talking about on the screen, by all means type it in and we'll experiment with it. This is meant to be a fairly organic format here. So if you know the topic shifts a little bit, as we're going, that's great. The entire idea here is for us to learn from each other as a community. So if you have a trick that relates to what we're talking about here, go ahead and throw it up, and let's show it to everyone. So the other thing that I wanted to show as far as the manipulators was the drag modes, and basically that's accessed up here in the heads-up display, and I'll use it showing the translate icon right now. And basically, right now it's set to world, meaning that whatever the world coordinates of the scene are, you're going to move in those coordinates. So this would be world Y, this would be world X, and this would be world Z. If I change this mode to construction plane, you'll notice that my construction plane happens to be set up on the XY, and my manipulator changes from world to C-plane. So now my Z has repositioned itself to now it's Z to the C-plane, and my X and Y are relating as would be expected. The green being the Y relates to the green and the Y in the grid. X being red relates to the X on the C-plane. The next mode would be view, and I particularly like this. Actually, let me jump into UVN first, and then we'll go into view. UVN works off the normals of the object, and you'll notice that when I switch to UVN, my manipulator now is set up so that it matches the X and Y, or the UV coordinates of the isoparametric structure, and then my Z is actually set up normal. And this is particularly cool for sculpting organic stuff and faces and things like that. So I can come up here and I can pick these, and you'll notice that it's manipulating normal to the surface and allows a fairly significant amount of control based on the model itself. So this is really a fairly cool ability in there. And then the other one that I really like is view, which is a two-dimensional manipulation based on the viewport camera view. So if you look at this, if I position this about here and I say, okay, I want this curve to be a little flatter, if I position it so that it's kind of in the window where I want it and then grab my C-plane icon here, you can see that I can go in and fairly quickly manipulate something based on the camera view. And then if I change the view, I can move it this way. And then if I change the view to a slightly oblique angle, I can continue. This is particularly useful if you're working on an object that's not set up in strict XYZ orientation, and you have to deal with stuff that may be you know, kind of at an angle or whatever to your construction plane. Now, obviously, you could go in and set up a construction plane based on the coordinates of that unit, but view is a really quick, simple way to kind of go in and grab something and manipulate it. Not as accurate as the world views, but it's really quick, especially if you're sculpting something that's fairly organic, which, let's be honest, that's what T Splines is all about, right? Okay, so those are my manipulator tricks. Well, actually, not all mine. I got those from everybody. The next one is from Juan, and I thought this one was awesome. And this is particularly useful if you're working on a model that has a lot of data. And right now, if I were to try and manipulate control points on this thing, I have no idea whether I'm picking one in the front or one in the back or anything like that. So it's fairly hard to keep it organized because everything is overlapping. There's a command in Rhino called call control polygon, and I'll leave this up for a second. Call control polygon. And if you invoke this, you'll notice what it does is it calls any of the backface points and makes them so that you can't select them. So I can't select a point back here on this, even if I drag select back here, you'll notice that no objects are added to the selection. My selection over here is empty. So I know I'm only dealing with the front face polygons. And it's view-based. You'll notice if I rotate that these points over here are not selectable, whereas the ones on the front are. These points over here are selectable, where the ones on the back of the nose and mouth are open, and things like that. So this is really, this was one of those ones that I've been doing computer modeling for a really long time, and every so once in a while I come across something where I'm like, oh, that's sweet. So this is one of them. So thanks, Juan. Appreciate that. Cull control polygon. So if you're working on stuff that has a lot of data, that's a really useful way to hide some of the points in the background. And it works in shaded view as well. If I shade this, you'll notice that it's fairly easy to stay oriented because I know I'm picking that point and not this one over here because it's been culled. So that's a cool one. That's one of my favorites. The next trick that we'll get into is the backslash hotkey override. And if you've watched me kind of stumble around through some of these webinars where Matt takes my hotkeys away, it's something that I use all the time. I use a ton of hotkeys, and what you have to keep in mind with T Splines is there's actually two programs running here. There's Rhino running in the background, and there's T Splines when the heads-up display is up is running in the foreground. So if you imagine this like two sheets of paper, the T Splines would be the top sheet of paper, and Rhino would be the sheet of paper underneath it. And when you go to enter a hotkey, if the heads-up display is up, T Splines is assuming that you want to use a T Splines hotkey. So say, for example, if I wanted to go to my top view, which in Rhino I have set up a custom hotkey, which is the T key. If I hit the T key, you'll notice that since the heads-up display was on, it's saying, oh, well, T is also the hotkey for moving the manipulator, which we talked about in the first trick. And it's asking for me to pick a point. Well, that's not what I wanted. I wanted my top view in Rhino, which is the Rhino hotkey. So I have to peel away the top sheet of paper and get to Rhino, which is underneath. And the way that I do that is by hitting the backslash key, which on a lot of keyboards is right between the right-hand backspace and enter keys. If I hit the backspace key, you'll notice that it allows me to enter, it's going to make a liar out of me. It allows me to enter a Rhino hotkey, which in this case is my top view. This is also, the same thing I run into is the P key is set up for the perspective view for me. And sometimes the P key brings up the paint mode, which if you hit the P key, you'll notice that it brings up the painting selection. Well, that's not what I wanted, so I have to shut that off. If I hit the backslash and then P, it'll take me to perspective mode. So if you listen to these webinars, you'll hear me furiously whacking on the backspace key, on the backslash key, in order to get my Rhino hotkeys activated. But this is particularly useful if you're doing something like, say I wanted to select a bunch of points up here. I could select a bunch of points and I wanted to set those to the X. I hit the backslash, this is the Rhino hotkey, and I set point. That allows me to bring up a Rhino command without exiting and having to shut off my heads-up display. The other way to do that is quite honestly to hit the control space bar, which shuts off the heads-up display, enter your Rhino keys, control space bar, bring your heads-up display back up, and that changes the priority between whose hotkeys are working. But the backslash key is a little faster, more efficient thing, and there was much rejoicing when the programmers threw that in, especially by me. So the next thing let's look at is how to create a specific shape for a hole. And I'm going to show two different versions of a technique here. And basically what I'm going to show here, let me hide this for right now. And the first way I'm going to show is if you were to take a plane, say for instance this was your model, and you were to blow a hole in it, I extruded an edge. In fact, let me go through and I'll show you this whole process. Let me get a face here. Okay, so I'm going to delete that. So I had a plane and I want a hole that's shaped like that. So the first thing I did was I just grabbed these faces and I deleted a bigger opening than what I needed. The next thing I did is I'm going to grab all the edges here, and in this case a cool selection trick is if I pick an edge here, shift click an edge here, shift click an edge here, shift click an edge here, and then hit the L key, you'll notice that L is the hotkey for selecting a loop of edges or points or faces or something like that. And the cool thing about that is I can just pick one here, one here, one here, one here, hit the L key, and bam, I get all my edges. Since I'm extruding, I'm going to extrude an extra face of an extra edge or extra ring of faces. And since extrude only works on exterior edges, it doesn't matter if this stuff is already selected. I can just hit the extrude button. It'll deselect the stuff that doesn't work, add an extra ring of edges in here, and I'm already set up to bridge from this to this. Now, one thing to keep in mind, I did set this up for maximum success in the fact that if you'll notice, when I select this edge loop, I have 22 edges. When I select this edge loop, it's going to let me do it. What am I doing here? Did I lock that then? What did I do? There we go. All right, so if I select this edge loop, I've got 22 edges. So I set this up for the greatest amount of success by making sure that both my edges match. So I'm going to pick one here. I'm going to pick one here. I'm going to hit the L key, and it will select the ring on both of them. So I'm going to pre-select my edges, and I'm just going to bridge. And since I picked an edge to start with, it's already set to, the selection mode is already set to edges. I'm going to right-click to accept. And I'm going to just use one segment to go from here to here, and it'll bridge in there, creating a specific shaped hole within the model. So, for instance, if you watched the helicopter webinar and you saw how I did the rear tail rotor, that's exactly how I did it. I got the hole somewhat close. I used an extra piece of geometry stuck off the back. I bridged to it, and then I deleted that original piece of geometry. And I could do the same thing here if I were to go in and grab the faces here, get rid of all of this stuff. Oh, you know what? I wonder if that polygon is screwing me up. Okay, I think that was the problem. There we go. So I can delete these faces, and now I have a specific shaped hole in my model. So it's a lot like if anybody's used that workflow where I know it was an old alias workflow a million years ago. If you wanted to build something tangent, you'd build a piece of geometry over here, if this was your model, and then you'd blend over to it or use a bi-rail surface or something over to it, and then delete the original piece of geometry. So that's one way to make a specific shaped hole. The other way that you could do that, get rid of all of this, is to do what we did before, which is pick edges, hit the L key to select the loop, and extrude. And in this case, I'm gonna pull this up a little bit so I have a little fillet here, and then I want to blend to another object here. The cool thing about one of the cool things about T Splines is that I can use this object here, which is, I'm going to join this because this is just a Rhino poly surface. You'll notice it's set up as a poly surface here. And this is a T Splines object, which I can confirm by hitting here. It says it's a T Spline surface. That's a poly surface. I can use the Rhino blend tool, blend surface, to blend between a T Splines object and a Rhino object. And you'll notice that that'll go in there, adjust it a little bit, fairly decently. And I'll get a nice blend between those two objects. Now it looks like I pulled that up a little squirrely, but you get the idea. If I change the properties on this so it looks a little better, and then shade it, you'll notice that I get a nice seamless blend. Nurbs object, T Splines object, all living and working together in perfect harmony. So that's another way that you could do this, is you can take a T Splines or a Rhino object, any type of Rhino shaped Rhino object with any type of shape that you want, and then you just use the Rhino blend surface tool in between these to create a seamless transition between these two. Now the cool thing about this is, since I didn't join this up or do anything crazy, none of this converted, so this is still T Splines, this is still Nurbs, this is still Nurbs. I can come in here and I can modify this, and it keeps all its T Splines goodness, but since I have a little space in here and I haven't messed up that transition, I can then go and say, okay, well, this is what I wanted, and I can take all this stuff and join it up. The T Splines object will convert to Nurbs, and I get an object with, if this was capped, but you'll notice that the seam down here is good, no naked edges around there. So doesn't always have to be a T Splines bridge, doesn't always have to be a T Splines transition. You can work within a model and use T Splines for what it's great at, use Nurbs for what it's great at, blend the two together. They can coexist in the same model, and then you can have these very mechanical, very controllable aspects of your model that can blend in with really nice organic pieces, and everybody gets along just fine. The next thing I want to show you is some tricks with symmetry. And in this case, I took a single sphere, in this case this one, and I applied radial symmetry to it with 4 sections. And the cool thing about this is, as I move this guy, you'll notice that it affects all the others, which also, if I turn my points on and I go to my top view, love that backslash key, and start pulling points, I can start to do some kind of cool sculptural stuff and watch it develop across the lines of symmetry. This would be particularly cool for the jewelry guys out there to do things like that. So you can apply symmetry not only to a single object, but you can apply symmetry to an object, and depending on where you set it up around the origin. In this case, the thing to keep in mind is that symmetry in this version of T Splines works around the origin. So everything that you do is set up around the origin. So let's look at how I set that up. And basically what I did was, if I take a single object and I apply symmetry to it, and it's going to be radial symmetry, I'm going to say yes, and I move this. Oops, that's not what I wanted to do. Sorry. That's the next version. That's the next step. Next thing I'm going to show you. All right, so I took an object. Come on. Take an object. It's simple, really. I don't want symmetry on this yet. So I'm going to take this and move it away from the origin. Now I'm going to use the symmetry tool, and I'm going to apply radial symmetry to this. And in this case, there was 4 segments. Let's change this to 6. And I'll get 6 total copies. And as I move this, you'll notice that it updates. Turn my points on. And I can start doing stuff like this. Then you could blend those together, convert them to Nurbs, do whatever you want, stuff like that. So that's how you can use symmetry on an object off the origin. So let's talk about using it on the origin. In this case, I'm going to use a torus. I'm going to put this around the origin. And you'll notice my options up here. I've got 4 vertical faces, symmetry's on, it's radial symmetry. There's 8 segments of symmetry, and there's 2 faces per segment. So let's break that down. So you'll notice that these are my symmetry segments here, 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 here. There's 8 of them going around. And then there's 2 faces per segment, and there's 4 faces going around this thing. So there's one here, one here, one here, one here. Let me change the color of this thing so you can see it. Okay, so if I go to my top view and I turn my points on, I can go in and manipulate this, and it reacts around the line of symmetry, or around the origin, which allows me to create some fairly cool organic stuff fairly quickly. And using my C-plane icons, oops, set up in view still. Whoa. You can come in here and do some pretty crazy shapes very quickly. And since this is a symmetrical object, whatever I do in one segment is going to get reflected along the others. So if I insert a point or an edge or something, you'll notice that the whole model gets subdivided. And if I manipulate that, that is reflected throughout the model. Very cool way to use symmetry to get some really crazy shapes really quick. Stuff that is obviously going to blend in and do all the great stuff that T Splines does so well. Fun with symmetry. All right. The next thing we're going to talk about is using curves to control shapes. And I get a lot of questions when I'm doing training about, okay, I see T Splines does all sorts of great stuff and it's super organic and it does all this, but I have to have something shaped. How do I make it specifically shaped? Well, in this case, and this is going to be a very simple example, but the application of it is fairly clear. In this case, you'll notice that I have 2 curves. These are just basic Nurbs curves. If I turn the points on, you can see what's going on here. And the key here was I picked these 2 curves and I rebuilt them at the same time so they have the same number of points. They should each have 8 points. And what I'm going to do is assume that this is like a shampoo bottle or something like that. So hide the points. I'm going to grab these and I'm just going to alt drag up. Now I'm going to pick an edge. I'm going to pick an edge. I'm going to hit the L key to select my edge loop. And I'm going to extrude down. And I basically, if I go to the top view, you'll notice that my curves are dead on. So what I'm going to do to create the volume of this thing is I'm going to use the bridge, and actually I'm going to pre-select these. So I'm going to pick an edge, hit the L key, and then bridge. I'm already in edge mode, so I'm going to accept that. And I'm going to change my segments to like 3, because that'll allow me to have 3 faces between the 2. And you'll notice that it bridges over nicely, and if I go back to my top view, my shape is still exactly what I specified with my original curves. Do the same thing for the bottom of the model. Pick both edges, hit the L key, bridge, All our settings are the same, so we select it. And you'll notice that we have a volume now. But if viewed from the top, our curves are still controlled. So to close up the ends of this thing, I'm going to pick an edge, hit the L key. I'm going to go to my scale tool, and I'm going to alt-drag on the center of the scale icon. And I'm going to bend that corner, and then I'm going to just suck this down to something like that. Hit the L key, alt-drag to bend the corner, and then alt-drag to make some faces. And then you can fill this hole any way you want. I'm going to just cheat and use the fill hole tool. Typically, I would subdivide this thing up a little bit so that all the edges flow and stuff like that. But for this purpose, I'm just going to take the quick route. So you notice that with the exception of our edge here, and I could have extruded out and then bent it over, but you'll notice that my curve is maintained here, my curve is maintained here, and I have my volume that I can then go and manipulate. And as long as I leave this row and this row of faces alone, my model is going to maintain that shape. So if I go to my face mode and I pick this row of faces and I manipulate it, I can change the volume of this bottle. In fact, you could do volumetric calculations if you needed to get it to be a certain number of ounces or hold a certain volume of liquid or something like that. You could actually use this to dial that number in exactly, which is really cool. And you'll notice that I can manipulate the shape on this thing, and my profile stays the same because I use some curves to begin with. Okay? So let's go to the next one, which is extruding to remove a crease. And this one is something that makes everybody who starts learning this program nuts. I know it made me nuts, and I know I've heard from a lot of you that it makes you nuts. And it's not because the program's broken or there's anything wrong with it, it's just the way that this thing works. If you have a nice smooth surface here, and say for instance this was the corner of a car, and I wanted to break open a spot in here to put a headlight in, it would make sense that I delete these faces, right? I have this beautiful smooth surface and I'm really happy with that, and I come in here and I pick these and I say, okay, that's where my headlight's going to be, and I delete it, and everybody freaks out because, oh my god, there's this big horrible crease running through the model and it's ruined and the software's terrible and Matt's an awful person and Tom hates me and all this kind of stuff. No, none of that's true. They're all good people and the software works great. The thing is, you just stopped too early and started freaking out. All you have to do is pick these edges and hit the extrude button. It'll add an extra row of edges, and you'll notice that all of your smooth goodness comes back, and you can alt-drag your headlight in, move your manipulator, go to your scale, and you have a nice opening with all the stuff that's maintained. In order to make a nice, smooth transition, T Splines needs to be able to calculate in all three directions. It needs to be able to flow in X, Y, and Z, or UVN in the model surface. If you go and you look at this before we extrude it, right now I can flow in this direction, I can flow in this direction, but I can't flow anything in this direction. So it's only got two pieces of the puzzle. This would be an unresolved inside corner. And so T Splines doesn't have any choice other than to assume that this is a crease. So what it's going to do is it's going to make the assumption that that's what you want until you throw in this third piece of information, which would be the depth, by extruding it. Now it says, oh, okay, well I can make this calculation now, so I know that that's smooth and the crease goes away, and that allows you to then go in and manipulate all this stuff. So all of you take back all the bad things you said about Tom and Matt and Adam. See, they really do like you. So that's how you get rid of creases. The other thing that causes creases is if I turn on my points and I were to unweld these points. Actually, I'd have to grab this and unweld this. Let's see, this edge. Okay, I just unwelded that edge so that basically these points are no longer coincident. And what happened is it just threw a whole bunch of creases through the model for the exact same reason that we had before. There's an unresolved inside corner here, and there's an unresolved inside corner here, and there's an unresolved inside corner there. There's only two pieces of the equation that T Splines needs to calculate smooth stuff. Okay, I can only go here and here, here and here, here and here, here and here. It's not able to complete the calculation. If you run into a situation, and this happens all the time, where you're knitting a couple of things together and you all of a sudden get this big, horrible crease running through the model. I've massively exaggerated this. In most cases, this is what ends up happening, is these points are coincident or close to coincident, and you're sitting there scratching your head going nuts trying to figure out why in the world, where are these creases coming from? Use your drag select and start looking at your points. You'll notice in the heads-up display, there's one vert here, there's one vert there, there's one there, there's one there. Everything makes sense. There's one there. Well, there's got to be a problem somewhere. If I drag select here, you'll notice, oh, there's two verts there. So there's two verts that are stacked on top of each other that aren't welded, which is what's causing this crease. If I pick those two and either hit the weld button or the Z key, which is the hotkey for weld, it sticks those together. All of a sudden, the calculation in three directions can be completed, and you get a nice smooth transition. All of your creases go away. All is right in the 3D world again. Okay? So if you run into a situation like that, look for two things. Look for stacked verts that aren't welded, and look for red dot verts, which are essentially the same scenario, but it's like a vert that's just out in space that doesn't have any relation to anything. Either delete those or weld them to something else, and most of your modeling worries will disappear. And the easiest way to do that is just to go through and drag select and check to see if you have any stacked verts. If there was a stacked vert here and there was a problem in this area, I look up here. If it says there's only one vert, well, I know that's not the problem. If I go down here and it says, well, there's two, well, that's your problem weld there. That'll also fix issues with symmetry and some other you can come up with that are common problems. Okay. The next thing I want to talk about is using, on a model that has a lot of data, and I'm going to bring this head back up again because it's way too complicated, but it makes a good example. This model right now, if I look at it in box mode, you'll see that it's all faceted. You can see each one of the quads broken out, and it's displayed in box mode. And you'll also notice that it's fairly snappy in box mode. I can whip this around pretty quick. If I toggle this smooth by hitting the tab key or the smooth toggle button, it's going to take a second. I get a nice smooth representation once it does it of the model. All the facets are gone. But you'll notice also that despite the fact that I'm working on a pretty burly machine with a pretty wicked graphics card, I'm starting to notice that I can't whip the model around like I used to. There's a little bit of lag. So the solution to this is in the T Splines option box. If I switch back to box mode, you'll notice that my performance improves dramatically. But I don't want to work with all those facets. If you go to the T Splines options, which are under the T Splines menu, all the way to the bottom, go to Help, Options, you'll notice that there's a setting in here called Smooth T-Mesh. If I click that, what it'll do is it will update the display in box mode to approximate a smoother model. And if I get rid of that, you'll notice that those quad facets have gone away, but it's a much cleaner approximation, but it's still, the performance on it is still really good. And so I can work on the model in a smoother, more recognizable fashion, but I still get the benefit of being able to work in box mode where everything works a lot faster. So if I go and pick an edge loop, you'll notice that in order to extrude this, in box mode it happens really quickly, whereas in smooth mode, you know, it's got to sit and do all those calculations and do all the interpolations and stuff like that. So it's a little bit faster way to interact with your model if you're looking at a big data set. So, smooth T-Mesh for faster performance. That's a good trick. And you're working in box mode. The thing that tripped me up when I originally looked at this was I was looking at it in smooth mode and I'd hit smooth T-Mesh and it didn't make any difference. And I thought, well, this is a stupid trick, until I realized that I was the one that was being stupid. You're working in box mode here. Smooth T-Mesh in box mode. All right. The next one is something Juan showed me, which I thought was really cool. And there's only really two ways to get a rounded corner.
To go to webinar, web events made easy.
Second. And try this a different way. If I make a box, and if I set my face to 1, 1, and 1, so that I'm making a simple 6-sided box, you'll notice that smooth mode actually gives me, and if I would have set that so that it was use snaps so that it was actually square instead of rectangular, you'll notice that I get a much different topology for a sphere. If I look at box mode, now I have smooth T-Mesh on, so you'll notice that as it's subdivided in box mode, I can still work on this smooth object even though I'm in box mode, but I get really awesome performance. So for this, let me shut that off. T Splines, help, options, shut off smooth T-Mesh, and you notice that's my box. So simple box, 6 sides. If I smooth it, I get a nice round object with a different topology than a radial sphere. And if I subdivide this using exact, do this a couple of times, you'll notice that I get a really different subdivision that may be much more conducive to sculpting stuff. And going in and using your UVN manipulators and all that kind of stuff is where you're going to be big in this. So for faces and things like that, this is a much better layout than the radial sphere, because stuff kind of makes more sense. There's 4 years of art school coming right at you. A lot of your work is already done for you here, just because the layout on this is a little better. Okay. So that's cool. 1 by 1 by 1 box equals better layout sphere. Subdivide it using exact by right-clicking on the subdivide button, and you get geometry that's a little better suited for sculpting stuff. Another one of Juan's that I'm going to steal and claim as my own. The next thing I want to show you, and this will be the last thing that I show for today unless some other stuff comes up in the course of our discussion, is the tsMesh and tsConvert commands, which is what you use if you were going to do an SLA output or convert to Nurbs and further work on the model. I didn't know this until very recently, is that these have history activated. So if I pick this object and I use the tsMesh command, I'll just use the default settings for example, you'll notice that I get a meshed object, but it kept my original T Splines object, and if I modify this, you'll notice, lo and behold, my mesh updates to match. This is about the coolest thing in the entire world if you do stuff that has to have a battery box in it. Say, for instance, you just built a big, crazy housing for some consumer electronic, and you went all the way through the process and exported this thing for STL, and you got it out of the vat, and you took it downstairs, and you went and tried to shove batteries in it and realized that something changed, some engineer somewhere made your life a nightmare and moved something, and now your batteries don't fit. Instead of having to go back and untrim the model, which is if you were doing this in Nurbs, you'd have to untrim it and rebuild everything and do all this kind of stuff. If you save this model at this point before you export your STL, all you have to do is go in, grab your point, move it a little bit, your mesh will update, export a new mesh, you're back in the vat, your batteries fit, and you're going home at 5 o'clock on Friday instead of midnight. A beautiful thing. We love that. So the other thing that this works for is if you convert this to Nurbs. If I click on the Convert button to change this to a Nurbs poly surface, you'll notice that my faces and all my T Splines objects are still there. My T Splines surface is still there. My poly surface is still there. These are historically linked. If I turn on my points and I pick a T Splines vertex and I drag this up, my Rhino poly surface updates. Again, this is really awesome if you're doing data transfer with somebody in Pro-E, SolidWorks, all this kind of stuff, and you send something down the line, since any type of imported data is going to be a dumb solid. If you import something and they get down the line and realize, well, there's an issue here, and I need a little bit more room here, a little bit more room here, I need that much more room in order to be able to fit my battery box or my circuit board or anything like that in, and they come back to you and they say, hey, there's a problem, this is where it is, this needs to come out a couple of millimeters, you double click it and say, okay, well, it needs to move out 3 millimeters. It just moved out 3 millimeters because I double clicked it using the trick we used in the manipulators. Moved it 3 millimeters, my poly surface updates, I re-export it back to Pro-E or SolidWorks or whatever. They import that object back into their model tree, the whole model regens, and you should be in good shape. So that's a very cool trick. Thanks to Tom for that one, and that's about, I think, we're getting close to our time here. It's almost 11, and which is perfect because that's all the tricks I have for you today. So I hope there's a couple of little nuggets in there that you could use. If you have other stuff that you like that you want to share, by all means, please throw it up so that we can get in there and share that stuff. So that's all I have for you today. If there's any questions, we'll hang out for just a little bit here and see if there's anything else that we can share or clarify or anything like that.
Thanks, Kyle. Just while we wait and see if there's any more questions, could you actually go ahead and pop open a web browser and pull up the T Splines training classes that we have coming up?
Yes.
So if you just go to the T Splines webpage, there's
Splines, not sploins.
Yeah.
T Splines will not get you there.
And then if you just click on the training link off the, I think it's community or support, there's a couple training classes coming up. There's one in San Diego or Carlsbad on, I think that's next week in October, one in New York November 11th, and then one here in Provo, Utah on December 3rd. And what we've done actually with these classes is we've been teaching these for 1 or 2 years, and we just recently kind of went through and gathered all of the knowledge that we've learned and actually created a whole bunch of new, simpler tutorials. And so If this was helpful today and you would like a little bit of this reinforced by going through a lot of tutorials that we don't have online with one of our trainers, then this is an option for you to come to as well. So again, just a reminder as you exit the webinar, if you wouldn't mind filling out that survey to help us improve these. And it just looks like there's a couple more questions for you, Kyle. Why do you have the smash icon in your load bar?
Let's see, smash icon. This up here?
I don't even think I know what the smash icon is.
This, let's see.
Help us out, Christy.
This is Explode. This stuff up here, this is Rhino Resurf. This is an extra plugin that I bought for surfacing Polygon files. You can find that in the Rhino resources area. I've been looking for I worked for Mattel for a number of years at Fisher-Price in Buffalo, and I did a lot of reverse engineering there through GeoMagick, and I've been kind of looking for a way to recreate that workflow for a number of years. And Rhino Resurf is it's a really inexpensive tool, and it kind of solved one of the problems I was having. It didn't do exactly what I wanted it to do, but it's for what it costs. I think it's like, $175 or something crazy like that. It's really super cheap for what it does, and it got me out of a bind, so I keep it. But that's what this stuff is up here. That's Rhino Resurf.
Let's see. I'm not seeing a lot of other questions. We haven't answered already yet.
Are you talking about this icon here? This smash icon? This is IrfanView. It's an image viewer. That used to be the old Rhino used to have actually the tool was called Roadkill back then, I believe. This is IrfanView. This is just a little free image viewer. I use it for looking at JPEGs and stuff like that.
Let's see, here's another question. The T to set the manipulator location will not work in UVN mode. Will this be changed later? We did that on purpose because when you are in UVN mode, changing the manipulator location is actually kind of confusing because it wouldn't really change the effect that it would still move the surface along the normal. So we did that on purpose, but we've got that question often enough that we'll make that more clear in the next version of T Splines, what's going on there. So here's a question, Kyle. What render program are you using?
Well, for the display here, this is Oxpecker, and I use this when I do the webinars just because it's a really great. It makes really great displays for live demonstrations. It's a plugin that was written by a guy named Hotkeys. I believe he lives in China, and he kicked around the Rhino forum for a long time and wrote this, and you can still find it kicking around in the web. The one thing I will tell you is that the new display pipeline for V5 is pretty much going to obsolete this. It's also only 32-bit, so it won't work in the 64-bit version of Rhino 5. But it's called Oxpecker, A-U-X-P-E-C-K-E-R. And you may be able to find it online. If not, I'd be more than happy to share it here. You can contact me, Kyle at theoutside.biz or Kyle at tsplines.com, and I'll be happy to send it to you via Dropbox or something like that. It's free, so no issues there.
So here's a question.
But as far as like production rendering stuff, I use Maxwell.
So here's a question about 64-bit T Splines. Let's go ahead and say it now. We're working really hard on T Splines version 3. Hopefully in the next week or so we'll have the first work in progress out for that. You'll that will be available to everyone that has a T Splines version 2 license. They can try out that whip, and that will have support for Rhino 5 64-bit version. Let's see, another question, Kyle. So with the convert to Nurbs, you can move any geometry while maintaining the T-spline? Does that make sense to you?
If you do, Booleans are not historically supported. So if you take two T-spline objects and Boolean them together, they will convert to Nurbs and Boolean together. But if you go back and try and modify the history, they lose their history when you do the Boolean operation. So I think what you're getting at, like say for instance, if I took two spheres and Boolean them together, would the history translate from the T-splines to the Nurbs through the Boolean so that if I modified the T-splines, the Boolean would update? No, it won't, because it loses the historical connection once you do the Boolean. That would be sweet, though, if it did that.
Here's a question. What's the toolbar at the right side of Kyle's window? I'm sorry.
This one?
I'm late. I wonder if it's the heads-up display, maybe?
There's the heads-up display here. This is Rhino Resurf, this stuff, and then this is the GoToWebinar control bar.
Which no one can actually see besides you.
No one can actually see.
Yeah. How can you control how tight the Nurb surfaces will be, i.e. positional tolerances?
As far as how tight they are in relationship to the T-splines object?
I think that's the question, yeah.
Well, it's my understanding, and certainly Matt, jump in here, that they're dead on with the T-splines object.
Yeah. There's actually, we don't really give you a choice. It's just, I mean, it exports so it's mathematically watertight. There won't be, I mean, you'll get the same shape, and that's one of the reasons why T-splines is growing and useful for CAD is exactly that. Nurbs compatibility is your Nurb shape will be exactly the same as your T-spline shape. There won't be any gaps at all when you go to different programs.
Yeah. The question just came up. Does T-splines and Rhino benefit much from a dedicated FX range video card, or would a good gaming card be as good? I actually had just been through that gauntlet myself as far as upgrading equipment and all that kind of stuff, and actually spent a lot of time talking to Jeff Lesor at Rhino. A good gaming card will work really, really good with Rhino. The problem when you start getting with gaming cards, I use a bunch of other different types of software, and one of them that I use is Freeform by Sensible, and they're really fussy about having a Quadro level video card. It just flat out will not work unless you have a Quadro card. I don't know why. It aggravates me to no end because the Quadros are really expensive compared to good gaming cards. I also know that back in the day, and I don't know whether this is still the case because they gave up on Alias years ago, that Alias Studio Tools had to have a Quadro card for some of their OpenGL overlays and stuff like that. I don't know if that's the case anymore. That may have been remedied, but that was one of the many reasons that I kicked those guys to the curb.
Could you quickly show again how you orient the manipulator normal to a surface?
Yes. Let me get rid of this, the poly surface. All you have to do is pick the object and change the drag mode up here in the heads-up display. Right now it's set to world. If I change this to UVN, it updates based on the normal of the surface. You notice here, and it's the best way to visualize it is just to watch where the blue goes. If I pick here, this is the normal. If I go here, that's the normal. If I go here, that's the normal. So you'll notice that the manipulator updates depending on where I pick on the surface based on the normal of the object. That's Matt's trick, and again, I'm going to steal it and claim it as my own.
So how are you able to keep the T-spline surface after converting to Nurbs?
It doesn't. It converts it, but it copies it. So instead of if I convert, you'll notice if I hover over this, you'll see the left mouse button is convert to T-splines. The right mouse button is convert to Rhino, Nurbs, or Poly surface. So if I right-click on that, all I have to do is accept it, and it converts. It copies the object and converts that copy to a Rhino Poly surface. But if you'll notice, if I go to my object selector in my pick menu here, there's a T-spline surface and there's a Poly surface. If I go back to the T-spline surface, and that was what we were talking about earlier, that's historically linked to the Poly surface. If I move that, then the Rhino Poly surface updates. So there's actually two objects stacked on top, stacked on top of each other. Excuse me.
Yeah, just to clarify, the reason why this is happening as it is because Kyle has record history enabled. If he turned off record history, then it wouldn't be doing this. And also, there's an option, if I'm not mistaken, when you convert to a Rhino surface, Kyle, that you can either copy it or not. So
okay,
there's that option as well.
Yeah. So if you notice here, when I grabbed the Poly surface and moved it over history, so now. If I move this, the T-splines object, it doesn't update the Nurbs surface. So, but with a little bit of planning and a little bit of forethought, especially if you're working in a pipeline with a bunch of other engineers and stuff like that, and your data is going to be traveling downstream and be in someone else's hands, it's a really cool trick to keep this history linked, because at a later date, if somebody comes back and says, "Oh man, I need 4 more millimeters here in order to fit the circuit board in," you just grab this, change this to your world, pick this, say 4 millimeters, boop, you've got 4 millimeters. So, and your Poly surface updates, and you export it, and they send it back in, they dump it back in their model, and they're good to go. So that's fairly awesome.
So here's a question from Kaminda. Is it possible to add edge loops that are not on the outer border edge of the surface?
So like say for instance you wanted to add a border loop like in here, what I would have to do is I'd have to subdivide this patch. So I'd just pick this patch and I'd subdivide it, and actually I want to do that exact so it doesn't change the shape. And you'll notice that by subdividing exact, it chased loops through the whole rest of the model in order to not change the shape. But then that allows me to come in here and I could subdivide these further and get, make a hole here. It's going to shoot creases through the model. Pick an edge here, 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 hit the L key to select those, and extrude. It's only going to extrude the exterior edges, and I can put a loop right there in the center.
I think the question may have been just inserting an edge loop that just anywhere in the middle of the model as well. If you can insert just a loop of edges.
Certainly, I can pick an edge loop here, and I can just insert an edge and drag that in, and that will throw another edge loop in there. Consequently, I can pick this one, throw another edge right there.
Yeah, and with the T-spline you can do that locally. That's actually where T-splines gets its name, is those little T-junctions when the surface is really smooth there.
Yeah, so with a typical sub-D modeler, this would have to chase all the way around. In T-splines, you can tee stuff off here, which is a significant advantage over some other, well, basically, let's be honest, every other sub-D modeler.
Let's see. So looks like Juan just answered this typing back, but this is a great question. Is there a way to flow a T-spline surface along a curve? Are you set up to show that, Kyle?
You know, I have never done that. Let's learn together. Let's try that. I'm going to just take I'm going to start with a Nurbs object. And I'm going to rebuild it. Something along those lines. I'm going to convert this to a T Splines object. And I'm going to stretch this out a little bit so that it's longer.
Do you know what will happen here, by the way, Kyle?
I think if I do it on the points, it'll work just fine.
Yeah, exactly. If you do it on the T-spline surface, it will convert it to a Nerb surface, and if you do it on the control points, it will keep it as a T-spline. So
yeah. So if I throw this up here, I'm going to just throw a couple of edges in here. One there. One there. So if I control points on and I pick these and I go to my UDTs and I flow this along a curve, I'm just going to use a line. It'll float along the curve. If I do it off the object, it converts it to Nurbs. So yes, you can flow a T-splines object. If you do it with the points, it stays a T-splines. If you do it on the object, it will convert it to Nurbs. I think probably what you would want is to convert it to Nurbs or to keep it a T-splines object. So in this case, you'd probably want to subdivide this thing a little bit more. Select your points, flow it, so that there's a little bit more information, and this stays a T-splines object here. Still editable and all that kind of stuff. That's kind of the rule with all the UDTs. If you want to use any of the UDTs, like say for instance you wanted to use the bend tool, I use this one a lot. Do it on the points. Bring this, grab bend it, and it stays T-splines. I use that all the time. I love the UDTs. I love them. I use them all the time, and the fact that you can use them on T-splines object is even awesomer, if that's even a word.
okay, well I think actually almost everyone is still here, Kyle, but questions have slowed down, so maybe we should.
You don't have to go home, but you can't stay here.
Okay. Well, thanks a lot.
Get out of here. Go make something. Thank you very much, everybody, for coming. I really appreciate it. I appreciate the time. I know everybody's time is tight, and it's really fun doing these. I hope you enjoy them. I really appreciate Matt giving me the opportunity to do this stuff. And by all means, if you need some help, reach out to one of us and let us help you out, and keep this party going.
Okay. All right. Thank you.
Bye, everybody.